Hi, welcome back to Music Chemistry. This is Stoichiometry Lesson number 1. Okay, stoichiometry is a method of conversion one amount of substance into another amount of substance. And we use a flow path. The flow path is described as my grams to my moles to their grams. This process can also reverse to their grams to their moles to my moles to my grams. So the process can go one direction, it can reverse and go the opposite direction. Remember that 1 mole is using Avogadro's number, which is 6.022 times 10 to the 23rd. It could be grams, atoms, molecules, particles, ion pairs, whatever. Okay? So let's look at the first question. How many moles of ammonia are produced when 7 moles of hydrogen gas react with an excess of nitrogen gas? Okay, so I've got 7 moles of hydrogen gas, and I'm going to convert it to moles of ammonia. So I'm going to need to use the ratio of hydrogen to ammonia. So I'm going to use this one and compare it to this one. So I've got moles of hydrogen on top, so I'm going to put moles of ammonia on top now. So I'm going to write 2 moles of NH3 on top and 3 moles of H2 on the bottom. Why do I want to do that? So that I can get rid of my common unit, just like I did. And this would become 14 divided by 3. So let's check that out. 14 divided by 3 gives me 4.67 moles of ammonia. Okay, so that's really easy, guys. See how easy that was? All right, now, here's your next question. If you have 42 grams of sodium chloride, how many moles do you have? Well, the first thing you need to notice, you notice that you got 42 grams. So to change that, you're going to have to know the molar mass of sodium chloride. So you come over here, you set up Na, and you put Cl. Well, Na is 1 times 22.99 grams per mole. Chlorine is 1 times 35.45 grams per mole. Right, so when we add these two together, we're going to get the following amount. So we go 22.99 plus 35.45, and that gives me 58.44 grams per mole. So I'm going to write 58.44 grams per mole of sodium chloride, right? So now I know what I want to do here. So now what I want to do is I want to convert grams of sodium into moles of sodium, right? So I'm going to go from my grams to my moles, just like that. So you go 42 grams, right, of NaCl times 1 mole of NaCl divided by 58.44 grams of NaCl. So our grams of NaCl cancel out, and that gives me an answer of 42 divided by the 58.44, and I'm going to get 0.72 moles. Pretty snarly of NaCl. All right, so now there's one more question from the answer above. How many ion pairs do I have? Now, what we're going to do is we're going to go and do something a little bit different, okay? We're going to go from my moles to my ion pairs. See? So how are we going to do that? Well, first of all, you go write down the moles. You know that you have 7.0 0.72 moles, right, of NaCl. And now we want to convert that into ion pairs, but we're going to have to use this number right here, Avogadro's number, right? So for every mole of NaCl, I'm going to have 6.022 times 10 to the 23rd ion pairs. So I'm going to go to 6.022 times 10 to the 23rd ion pairs. I'm just going to call it IP over 1 mole of NaCl. Well, those moles cancel out, and that gives me an answer of calculating it now, guys. And here we are, 4.33 times 10 to the 23rd. So it's going to be 4.33 times 10 to the 23rd ion pairs. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Musin Chemistry.